So before I start my talk, I want to do a very brief survey. Have you heard of OceanBase? You raise up your hand. Yes, we just talked before several minutes ago. Yes, okay, thank you. So because it is a code data, some are AI and OceanBase is a database. Actually, OceanBase is a very well-known database in China, and also we have some lighthouse customers in Southeast Asia, but it's not very popular here. So today I want to talk about OceanBase from OLTP to all-in-one database. Our product vision is to use one unified database to solve 80% of customers' data requirements, including OLTP and also OLAP, AI, search, multimodal, and so on. So in only one database, 80% of our workload. We are an open source, cost efficient, and high performance SQL database at scale. OceanBase is super fast. We broke the TPCC record twice in 2020 and 2021. And now, OceanBase, the TPCC resides in the top three for both TPCC and TPCH using one HTML engine. OceanBase achieved 61 million QPM and peak traffic during Double 11 shopping festival. Yeah, this performance is very, very high compared to the peak traffic at Visa. It's about more than 8 times compared to Visa. Yeah. So OceanBase can reduce TCO because of our cutting-edge conversion technology. We can reduce by about 70% to 90% storage cost. And also we can use our multi-tenant architecture like some cloud database architecture to achieve database consolidation. So the database resource utilization is much higher compared to traditional database like Oracle or MySQL. We can use OceanBase high availability architecture to achieve RPO equals 0, RPO less than 8 seconds. In this lab, in case of failure, no matter machine failure or IDC failure or even city failure, city crash totally, OceanBase can recover in less than 8 seconds without any data loss. This is the real case in Alipay and also the real case in OceanBase more than 1,000 customers. We have more than 1,000 customers, including all kinds of industry. This is our brand, including the largest bank in China, ICBC, the largest telecom companies in China, China Mobile, the largest insurance company in China, China Life, and also the largest oil companies in the pack, the largest power companies, Grid, and so on. And also we have some customers in Southeast Asia, like Dana. Dana is the largest mobile wallet in Indonesia, and Gcash is the largest mobile wallet in Philippines, and also Haidilao Hotpot. I think most of you are very familiar with Haidilao Hotpot and Starbucks. So, but from this logo, you can see that about 95% of our clients comes from China, and maybe less than 5% are here. So this is why you are not too familiar with OceanBase. But maybe just 1 year or maybe 2 years later, you will be very familiar with OceanBase. Yeah. Our team is committed to building a native distributed SQL database. It is a distributed SQL database. So we started our project from 2010, actually more than 14 years until now. And first, it is a write one, read many architecture. Only one node can read, and all the other nodes can only one node can write, and all the other nodes can read in our first architecture. And in 2016, we announced our fully distributed architecture, which is OceanBase version 1.0. In this architecture, all nodes can both read and write. So it is a fully distributed architecture. In 2022, we published our OceanBase version 4.0, which is a monolithic and distributed integrated architecture. It means that in OceanBase version 4.0, it can not only support distributed deployment, but also it can support standalone deployment. Even we have only one machine, or even our laptop, we can use OceanBase version 4.0. Yeah. And in this year, we published our OceanBase version 4.3, which is a all-in-one database. This is my today's topic. This is our architectural view. As a bottom layer is our distributed storage layer with ACID transaction in a distributed environment. So in our architecture, each partition has several replicas. And some replicas we can use row store to handle OLTP workload, and some replicas we use call store to handle OLAP workload. And we can also have, on top of our distributed storage layer, we support all kinds of multi-model data types, not only scalar data types in traditional OLTP database like Oracle, and also some semi-structured data type like JSON, XML, array, GIS, and also vector data type, which is used by vector engine, vector database. And as a top layer is our multimodal computer layer for hybrid workload, including vectorized execution engine, parallel execution engine for OLAP workload, and effective OLTP, OLTP execution, advanced serial optimizer, and multimodal API, and so on. I have told you before that the peak traffic of RDK download level is more than 8 times compared to Visa. We have about more than 140,000 TPS in the peak traffic. So the performance of OceanBase is very high. OceanBase has supported all mission-critical business in Alipay, including the trading business in Alipay, the payment business, the accounting business, customer information, promotion, real-time data service, and so on. So we have lots of clusters in Alipay. The largest cluster in Alipay has more than 200 nodes, and one single paper has more than 350 billion number of nodes. And we have used OceanBase to achieve disaster tolerance, RTO equals 0, RTO less than 8 seconds. It means that in case of some extreme failure, like a city total crash, like maybe you know that Alipay, next one city in Alipay is Hangzhou. Even Hangzhou crashed totally. The service of Alipay will not be affected. Just in less than a second, we will cut automatically. So we broke the TPC record twice in 2020 and 2021. OceanBase is the first distributed database to pass TPC test. So in our TPC benchmark test, we use more than 1,500 nodes in one cluster, and the performance is very stable. From this chart, you can see that the performance jitter is less than 1% during the steady state operation. The steady state operation lasts for about 8 hours. And we use lots of features like optimized two-phase commit protocol for distributed transaction, and also like spot procedure, PL cycle, to accelerate the performance of TPC benchmark test. There are also other distributed server database in the world like CockroachDB and YugabyDB. Maybe somebody have heard of CockroachDB, YugabyDB, and like TiDB. OceanBase is also distributed server database, but the difference from this distributed server database is that OceanBase is much faster. We use Dispatch to compare the performance of OceanBase with the other distributed database, and the performance of OceanBase is for about 3 to 10 times that of the other distributed database. So OceanBase is very, very fast. Why? Number one, the architecture of OceanBase is much better. Number two, the engineering and the engineers in OceanBase team is much better. Number three, we have lots of distributed transaction related innovation in our OceanBase database, and we have published our works in the top conference like VIPP, very large database component, which is the very famous component for our OceanBase paper. Although OceanBase was well known as an OLTP database at first, but we find more and more users they use OceanBase in other scenarios like OLAP, vector database, search, multimodal, and so on. Why? Because OceanBase is a distributed database. So we have solved the problem of large volume data. So you know that like some maybe non-stable database, like a key value database. The major problem, major challenge of key value database is large volume data. How to achieve scalability? OceanBase has solved the scalability and high availability problem in our distributed architecture. So it can be also used in other scenarios like key value, NoSQL, OLAP, and so on. So the underlying technology includes our all-in-one storage engine, all-in-one transaction engine, all-in-one field engine, multi-model, and all-in-one multi-cloud architecture. So I want to talk about HTAP. We can handle both OLTP and OLAP in one unified system. There are two methods. The first method is that we can use one cluster. Because as a distributed database, each partition has several replicas. So in one cluster, we can use some replica to handle OLTP workload. They use row store, and other replica to handle OLTP workload. They use column store, right? So this is one cluster approach. Another approach is two clusters approach. We can use one cluster to use row store to handle OLTP workload, and another backup cluster to use column store to handle OLTP workload. So these two clusters are both used in HTAP database. The advantage of one cluster approach is that the cost is much lower because we only use separate variables, not a totally different system. And the latency between replicas are relatively low compared to two cluster methods. Yeah, this is the approach used by OceanBase. But yeah, there are some challenges. The challenge of one cluster method is the engineering effort is much higher compared to two cluster method. We use LSM tree, block structure merge tree, LSM tree like storage engine in OceanBase. So when data is written into OceanBase, it's written into memory at first. Our data structure in memory is called memory table. It's ordered by row key. The table has a row key, ordered by row key and row by row. And after the memory, after we write the memory and write as threshold, we will close the memory table and then dump the memory table into an SS table, store the SS table to disk. So the stored SS table in OceanBase, if we use row store, the layout is the text-like page layout. An SS table has several pages ordered by row key. And in our text-like page layout, each page, and each page is the data is organized with each page column by column. Column 1 at first, and column 2 and column 3. So it's a traditional like text-like page layout like in other big data system, very similar. So by using text-like page layout data structure, we can use one copy of data to support both OLTP and complex query workloads because both OLTP and also some complex query are fast, very fast using this data structure. Another data we also support column store. We still use LSM tree like storage engine to support our column store. But the page layout of our column store is different from our row store. In our row store, the page layout is text-like page layout, but in our column store, each table has separate columns. And each column forms an S table, and it's a column store. Column only one, each column S table stores only one column. So because only one column, so only column data from that column. There are two kinds of workloads in our system. The first workload is OLTP enhanced mixed workload. For example, real-time decision, risk control, or maybe some fraud detection scenario in a lot of fintech company and bank. In this kind of scenario, because in most cases, this kind of scenario are relatively lightweight, not too heavy. So we can use low-score packs like page layout as the primary replicator, and also we can add one corresponding index, not corresponding, just corresponding index with packs like low-score to handle this kind of H-type workload. All OLTP workload has some complex query handled by the primary replicator, only primary replicator. So there is no latency between OLTP and OLAP, and both TP and real-time OLAP are very fast. Another kind of workload is OLTP enhanced mixed workload, like quality real-time decision analysis. This kind of workload, in most cases, are relatively heavy compared with the first workload. So in this workload, in most cases, we use low-score primary replicator to handle OLTP, and we use an independent read-only core replicator to handle OLTP. So by using this kind of deployment architecture, we can know that we can handle relatively heavy OLTP workload, but that's latency between OLTP and OLAP. Another kind of H-type, in my opinion, is integration of distributed OLTP core capability into OLAP system. You know, traditional OLAP systems, they are very powerful. In OLAP query, big query handling, they are very powerful. OLAP ecosystem, data importing and processing, batch processing, they are very powerful for traditional OLAP system. But traditional OLAP systems, they don't support some useful features like real-time writing, real-time study. They don't support real-time. And most of the OLAP systems, they are not very easy to use. So by combining both the advantage of OLTP and OLAP like OceanBase, we can get a much easier and real-time, totally new OLAP system. So in OceanBase, because we have already supported OLTP features like MySQL compatible, real-time writing, real-time study, secondary index, OLTP query, high concurrency, high availability, high availability, disaster recovery, upload equals to 0, upload less than a second. So when we build OLAP on top of our distributed OLTP capability, we can combine both the advantage of OLTP and OLAP and get them much easier to use real-time OLAP database. So we also have a lot of clients that use OceanBase in their OLAP scenario. Like because they need real time, they need easier to use, they need a MySQL compatible data warehouse, not a very hard to use data warehouse. For example, we can use our OceanBase real-time OLAP to build a lightweight real-time analytic database. So you know, in a traditional OLAP scenario, data is processed layer by layer, from OPS layer, operation data store layer, to several middle layer processing, like data warehouse detail, data warehouse service, several middle layer, and finally, ADS application data service layer. So by using OceanBase real time, we can support not only batch processing, batch transforming, batch big query, and we can also support real-time writing and real-time study. This is very, very different. OceanBase also broke the TBCH record. You know that the TBCH record is for OLTP and TBCH record is for OLAP. So we broke the TBCH record in 2021. So yeah, so we are still the top 3 in our TBCH record. There are another benchmark which is very popular called Curly Bench, which is used in real-time and limited scenario. So We also compare the performance of OceanBase with ClickHouse using ClickBench. From this table, you can see that although OceanBase is an OLTP database at first, but the real-time OLTP performance of OceanBase is comparable to ClickHouse, which is the fastest OLAP, real-time OLAP database in the world. So both the OLTP and the OLAP performance of OceanBase are almost the number one in the world. OceanBase also supports multi-model. In our multi-model architecture, at the bottom layer of our architecture is our integrated architecture. We can use one system to support standalone deployment and also distributed deployment. We can support shared lasting deployment using an on-premise and shared storage deployment of public cloud. On top of our integrated architecture is our table structure, including row store, column store, and then we support all kinds of API, table API for key value, requirement key value, readable key value write, and HBase API, and also SQL compatible, MySQL and Oracle compatible features. So OceanBase is very stable because we support mission critical OLTP features. It's highly available, scalable, resilient to failure, and no latency. So on top of our integrated architecture, data structure, APIs are all kinds of multi-model, including table, key value, document, vector, white column, and so on, and also OLTP and OLAP. The advantage of OceanBase multi-model is that because we can share the same underlying architecture, so OceanBase is very stable. Our multi-model feature is also very stable, right? In our multi-model architecture, instead of having a particular kind of database, we need to support maybe one new model. We don't need to add a specific standalone database. We just add an interface. It's very easy. It's much easier compared to a standalone database. OceanBase supports unified language. We call it SQL class. In our SQL class language, we can support not only OLTP, OLAP, but also some semi-structured language, semi-structured data like JSON, like XML, like GIS, and vector, and so on. We also support some compatible features like MySQL compatible, Oracle compatible, HBase compatible, Redis compatible, and maybe in the future we'll support like MongoDB compatible. We can just add one interface for each data model, each new data model. So yeah. OceanBase supports vector data type using our multi-model architecture. So vector type in OceanBase is not a standalone database, it's only a vector data type. In our vector data type, we support all kinds of built-in vector types and indexes, including SQL syntax, distance calculation, vector indexing like HNS-W indexing, which is very popular by Facebook, by Meta, and also pooling query, top and approximate query, similarity search, which is very useful in AI, large language model. I have mentioned before that the advantage of OceanBase vector engine is our capability. It's our underlying integrated architecture and the related capability, including high availability, high scalability. It's very stable, it's very easy to use because it's compatible to MySQL, and we support a full view of operational tools, no matter including backup, storage, all kinds of tools. We are supporting naturally. We can use OceanBase vector engine to build a very popular application like RAG, which is very popular. For example, we want to use OceanBase to build a document search system using natural language. Yeah, OceanBase will also, we have a website. Our website is a document search using natural language. For document search system, we want to use natural language. So Firstly, DBA just insert lots of embedded data to our vector database from our knowledge graph. DBA has lots of knowledge graph. They can do embedding at first and insert the embedded data to our vector engine, our vector database. And then, if user want to ask some questions in our document system, for example, the user wants to search how to create vector index in OceanBase. So we will do embedding at first, and then we can use our OceanBase vector engine to do similarity search, to search the relevant information from our knowledge graph. And then we can use the question and the vector info to go to the large language model to get the more accurate info. So the answer by using RNG is much more accurate compared to original answer. In OceanBase, AI technology are also used in all kinds of tools. There are many. In OceanBase, we have two kinds of tools. The first one is the administrator tools for DBA. Another kind of tools is developer tools for application developer. So in administrative tools, we use OceanBase, we use AI technology to achieve most of the work. For example, we use AI technology to achieve automatic diagnose. We need AI technology. Yeah. If we have some problem, we can use AI to detect the reason why the problem happened. And in our developer tools, the developer tools of OceanBase is called ODC, OceanBase Database Developer Console. So we can use large language model to achieve ODC compiler. Yeah. So yeah, I think maybe it's a text to speak tool. So when we want to do something, we don't need to write a single language. We just use the natural language, and we also ODC will generate a SQL statement according to the natural language. The underlying technology including textbook SQL, SQL generation, SQL rewrite, SQL collection, order generated notation, and so on. So, because OceanBase is a database, so we have a very big ecosystem. So, in OceanBase, we support multi-cloud, including AWS, GCP, Alibaba Cloud, Tencent Cloud, and Huawei Cloud. So, all kinds of clouds are supported in OceanBase. And we support some cloud-native tools like Terraform, like Kubernetes, and also we support all kinds of operating system, Linux operating system, and CPU, like Intel CPU, ARM CPU, AMD, and so on. So we can be integrated to big data system, including Databricks, Snowflake, and also some string system like Blink, Kafka, and so on. And also we support like some useful BI and development tools and ORM management tools and so on. So by now we have supported more than 100 ISV partners and more than 340 partner solutions, more than 50 reseller partners and more than 20 delivery partners, and the total technology integration are more than 750. This is our very brief roadmap in 2024. So the major goal of our 2024 is make OceanBase from an OLTP database to all-in-one database. So in Q1, we announced our form store table and vector distribution engine to enhance our OLAP capability. In Q2, we support forecast index and general market value index to support the more semi-structured data structure. And in Q3, we support vector plugin for AI. So our vector database will be announced just maybe in 1 month later. And in Q4, we will support storage and compute stability based on S3. Actually, because OceanBase has lots of clients on the public cloud, so we have already support already supported storage and compute separation. But by now, our storage and computation separation are based on cloud disk. You know, cloud disk is very expensive. So after we support storage and computation separation based on S3, the total solution of OceanBase on the public cloud will be much cheaper. So thank you, and hope that you can enjoy it.